You are, right now, about 60% water. Every tear, every heartbeat, every thought running through your brain, it's all happening in liquid that is, by any reasonable estimate, older than the Earth itself. Here's the part almost nobody knows. Earth should not have this water. Not this much of it. Earth formed close to the Sun, in a part of the solar system that was, by every law of physics we understand, too hot to hold on to water at all. So something happened. Either something from outside Earth delivered trillions of tons of water after the planet had already formed, or Earth pulled off a trick that, as of right now, scientists are still arguing about. And the argument is messier than you'd think. For 50 years, scientists have been building a case file on this exact question. There have been 3 suspects, 2 total reversals, and, in just the last 2 years, a piece of evidence that reopened a case everyone thought was closed. By the end of this video, you'll know exactly how little anyone actually agrees on where the water in your own body came from. To understand why this is a mystery at all, you have to go back 4.6 billion years, before Earth existed, just a flat disk of gas and dust spinning around a newborn sun. Astronomers split that disk into 2 zones with an invisible line called the snow line. Inside the line, where Mercury, Venus, Earth, and Mars would form, it was too hot for water to exist as ice. Any water molecules that formed there got boiled off by the young sun almost instantly. Outside the snow line, out past where Jupiter sits today, it was cold enough for water to freeze solid and stick around. Earth formed inside the line, which means, on paper, Earth should have come out of the oven bone dry, a scorched rock like Mercury, not a blue marble. And yet, 71% of the surface is ocean. To put that in perspective, if you gathered up every ocean on Earth into a single sphere, it would be nearly 900 miles across, big enough to stretch from New York to Chicago and back. All of it made from water that, according to the physics of how this planet formed, should not exist here at all. This isn't just trivia. It's the same question scientists are asking every time they point a telescope at a distant moon or a far-off exoplanet. Because everywhere in the universe, water is the #1 clue for where to look for life. Solve the mystery of how Earth got its oceans, and you get a working playbook for where else it might have happened. So who, or what, actually gets the blame? Suspect number 1 had been under suspicion since the 1980s, and it's the one you'd probably guess first: the comet. Comets are essentially dirty snowballs left over from the outer solar system. Objects like Halley's Comet that spend most of their lives in the deep freeze past Neptune, then swing in toward the Sun on wild, elongated orbits. If anything in the solar system was carrying frozen water, it was these. In 1986, when the European probe Giotto flew past Halley's Comet, scientists got their first real chemical read on cometary ice. They were looking for a very specific fingerprint, the ratio of a heavier form of hydrogen, called deuterium, to ordinary hydrogen in the comet's water. That ratio works almost like a birth certificate. Water that formed farther from the Sun, in colder conditions, tends to carry more deuterium. Compare a comet's ratio to Earth's ocean ratio, and in theory, you can tell if they're a match. Halley's water came back with too much deuterium. It didn't match Earth's oceans, which, for a comet, is the scientific equivalent of a bad alibi. But one comet isn't a verdict, so the case stayed open, and Comet stayed suspect number 1 for the next 30 years. Then came Rosetta, and 30 years of comet suspicion collapsed in a single measurement. In 2014, The European Space Agency parked a spacecraft in orbit around Comet 67P and dropped a lander onto its surface, the first time humans had ever landed on a comet. Rosetta measured 67P's water directly, and the result made headlines. The deuterium ratio was 3 times higher than Earth's oceans. Not a partial mismatch, a hard no. Multiple follow-up studies piled on. Researchers modeling the total water budget of the early solar system started putting hard ceilings on how much of Earth's ocean comets could possibly account for. Some estimates said less than half, others said less than 10%, and one analysis using noble gases put the cometary contribution at under 1%. Comets, the original suspect, were looking more and more like they'd been in the wrong place at the wrong time. The investigation needed a new lead. Suspect 2 had been sitting quietly in plain sight the entire time, waiting to be taken seriously. The asteroid belt. Asteroids don't carry water as visible ice the way comets do. Instead, a specific class of them, carbonaceous chondrites, some of the oldest, most primitive rocks in the solar system, lock water directly into their mineral structure, bound up inside clay-like minerals instead of frozen on the surface. And when scientists measured the deuterium ratio in these asteroids, it lined up with Earth's oceans far more closely than any comet ever had. Not a rough match, a genuinely convincing one. There was also a delivery mechanism ready-made for the job, a period roughly 4 billion years ago, sometimes called the Late Heavy Bombardment, when the orbits of the giant outer planets shifted and flung huge numbers of asteroids, and whatever comets remained, into the inner solar system, hammering the young Earth, Moon, and Mars with impacts. Creation sample return missions have only strengthened the case. Scientists studying material from the asteroid Ryugu found direct evidence that liquid water had once flowed through its parent body, exactly the kind of primitive, water-bearing rock that could have seeded early Earth. By the 2000s, this wasn't just a theory anymore, it was close to consensus. Asteroids had the right chemistry, the right timing, and physical samples in hand to back it up. Case closed. Or so it seemed. Here's where it gets genuinely strange, and where this case file has to be rewritten from what you might have read even a year or two ago. In 2024, a team of scientists went back and re-examined Rosetta's original data on Comet 67P, the measurement that had ruled comets out in the first place. They found something the original analysis had missed. At the exact moment Rosetta took its reading, the spacecraft was flying through a cloud of dust surrounding the comet, dust that itself carried heavy water and may have contaminated the sample. Strip that dust contribution out, and 67P's actual icy body may have looked far more Earth-like than anyone realized. Then, in 2025, astronomers turned their instruments on a different comet entirely, 12P/Pons-Brooks, and measured its deuterium ratio directly. The result matched Earth's oceans closely. So the comet that got the whole case thrown out 30 years ago may have been misread. And a brand new comet just walked back into the lineup as a serious suspect. One planetary scientist studying this put it bluntly. It was probably a combination of all of them. Let's take stock, because at this point, the case file has more reversals than a legal drama. Comets, ruled out, then possibly unruled out. Asteroids, still the strongest physical evidence on the table. And there's one suspect we haven't even brought in yet, one that doesn't involve anything falling from space at all. That third suspect is the strangest one on the list. What if nobody delivered Earth's water because Earth never lost it in the first place? The idea is that the raw, rocky material Earth formed from, even inside the supposedly dry snow line, already carried trace amounts of hydrogen locked into its minerals. Not liquid water, not ice, just hydrogen atoms trapped in rock. Given billions of years, a molten early Earth, and enough volcanic activity to slowly release and recombine that trapped hydrogen with oxygen, the planet could have, essentially, built its own oceans from the inside out. No comet or asteroid delivery required. Which is either the least romantic origin story you've ever heard, or the most, depending on how you feel about volcanic rock. It sounds like a stretch, until you look at the moon. The moon was thought to be completely bone dry, until researchers re-examined Apollo lunar samples and found trace water locked inside volcanic glass beads. Water with a deuterium ratio suggesting it came from inside the moon itself, in a place no comet or asteroid impact could have reached. If the moon, which formed from the same violent Mars-sized object collision that reshaped early Earth, could hold on to homegrown water, Earth plausibly could too. Which means the leading theory today isn't really a single suspect anymore. It's all three working together. Some water baked into Earth's original rock, some delivered by asteroids, and some delivered by comets that were only partially ruled out in the first place. So here's where the case actually stands. After 50 years, hundreds of millions of dollars in space missions, and multiple total reversals, scientists still don't have a single confirmed answer for where the water in your body came from. What they do know is this. Every glass of water you've ever drunk is a mixture of ingredients with three possible origin stories. Rock that's been here since the planet formed, ice from a comet that crossed paths with Earth billions of years ago, or minerals from an asteroid that used to drift quietly between Mars and Jupiter. Remember that 60% of you that's water? None of it has a confirmed birth certificate. Every time you go swimming, take a sip from a glass, or just breathe, you are quite literally made of unsolved science. And somewhere out there right now, another spacecraft is on its way to another icy world, carrying another instrument built to take one more measurement on this exact question. Because for scientists, and for you, the case is still open. If you had to bet right now, comet, asteroid, or homegrown, drop your verdict in the comments. I'll pin the most convincing one. And if you want the next case file, why the moon exists at all, and the collision theory that's stranger than most people realize, that video's live now. Subscribe if you want to keep chasing these mysteries with me.